Hello and welcome to this partner webinar with Ignion, a hardware designer's guide to cellular IoT antenna design. So today's host, let's first introduce Jaime. Please tell a little bit about yourself.
Hi, good morning, good afternoon, everybody. My name is Jaume Anguera. I am a founder and CTO at Ignion.
And Johan, please introduce yourself.
Good morning, all. My name is Johan, and I'm in charge of business development with Ignion. And we are excited to be here together with the guys from Nordic to talk about development of antennas in cellular IoT.
Nice. And last, it's me, Martin Lessund. I'm a technical marketing manager from Nordic Semiconductor. So let's just jump into a little bit of the practicalities for this webinar. It will last about between 50 to 60 minutes, depending on how many questions we are getting. So questions are encouraged during this webinar. You can ask your questions in the top right sidebar, and all the questions are anonymous. And also try to keep them relevant to the topic to today's webinar. We will answer all the questions that we see at the end, and we also have a chat functionality in the webinar platform. This is not should not be used for questions, but can be nice to use to just have a little chat with the other community. If you have any questions after this webinar, you can go to our website, DevZone, if it's Nordic related, or you can go to Ignion's engineering support if it's antenna related. Also, our recording and the slides for this webinar will be available after the webinar on our webinars.nordicsemi.com site. So first off, a little bit about what we at Nordic want to do. We want to make the journey for the customers as easy as possible for each section. We have created the best-in-class SoCs and also the 9160 system in package. We make unique performance connectivity stacks and comprehensive SDKs, the NRF Connect SDK. We make hardware development kits and also software tools to have on your computer to work with our development kits and or your custom boards. Also, we have a vibrant community and technical support forum on DevZone. Also, we have different partnerships with the network operators with regards to cellular, and also cloud connectivity partners and solutions that you can connect to. NRF Cloud is also a site that we host different cloud services. This is also some value-adding services to any cellular product. And last but not least, our partners, design partners and solution partners. And that's where Ignion is coming in. I'm going to talk about what they provide for customers. So we have this Nordic partner program. We have a design partners that can help you from idea to solution, and solution partners, which comes with the different services. And as you can see, Ignion is one of our antenna partners. So why did Nordic and Ignion partner up? So Nordic is a world leading in low power wireless solutions, and Ignion is world leading in antenna manufacturing. So it was a obvious step for us to partner up with these guys. And antenna is the crucial part of any wireless design, especially for cellular designs. So that's why customers need someone to help them out to make this best as possible. Because if you have a bad antenna design, this will affect power consumption and also the quality of your product. And you can also affect it as much as if you have a GPS on your design, you can suddenly don't get a GPS fix because of the antenna design is too bad. So antenna design has traditionally been difficult and is often considered too late in the process. And that can also affect the quality of your product. So this should be considered as early as possible. Ignion is, of course, going to talk more about this. And ease of use is both in Nordic's and in Ignion's vision. So together we want to help benefit customers. Ignion provides a solid solution for Nordic customers, and they are going to talk more about this now. So let's go over to Ignion's presentation.
Thank you, Martin. Do you see my screen?
Yes.
Fantastic. So yeah, we are very happy to partner with Nordic, and for those of you who have been using the Nordic Thingy 91 platform, I also sit with one here, and I show this on the screen. You see the red antenna that's on there. That is a virtual antenna component called Trio from us from Ignion. We share the vision with Nordic on making it easy to develop great IoT products. And the virtual antenna technology really makes it a lot easier to ensure that you get great RF performance in your device. And on this thingy, you see the Trio being the virtual antenna. It is a non-resonant component, and you choose the frequencies where it's going to operate through a little matching network of a few components that defines what frequency your device should work at. And then it uses the ground plane to radiate. So it's the ground plane that will be your sort of your main part and sharing the RF. Jaume will explain a lot more in detail on how to design the whole journey, on how to design with this antenna technology. But one of the key advantages of the virtual antenna technology is that it's very predictable. And that has enabled us to build models on that we can predict how your antenna will perform even before you build anything in hardware. And these models, we put them in the cloud and introduce this, what we call the Antenna Intelligence Cloud. So we are now able to prototype the antenna solution in the cloud before building any hardware. And this really enables you as hardware developers to speed up your development and also anticipate any issues you would have further down the line in certification. I wanted to show this tool in a little live demo. And you can do this with me. We will go to ignion.io/Nordic. You can also scan this QR code. And then if Peter will allow me to share my browser window. All right, can you see that now? So here I am on the Antenna Intelligence Cloud tool that we have online. And here you simply just go in and you select what communication standard you're using in your product. So now I want to do an example of an LTE product, LTE Cat-M, and then I select the frequency range I want to operate at, and I select how large my PCB is, and I put in my application, and then the system can, you can choose one of our 6 antenna parts, but I want Ignion to recommend a part for me, for my product. And then I put in my name. And then what happens is that actually in a matter, now this takes maybe 1 minute to fill in. And then in a matter of sometimes a few minutes, sometimes a few hours, depending on the workload we have on the cloud, you will receive your new design. And this really enables you to get a head start in your antenna design process. So now I will click Submit Antenna Design Request. And then the cloud will now simulate the performance and come with recommendations on how I should develop my antenna system for the requirements that I've put in. So if I then go and share the report that I receive, so I'll just switch the window here again. So the report that I receive in a matter of a few minutes is this one. So then after you filled in this form, you receive our Antenna Intelligence Cloud report. In here, you see the requirements of what you put in. So I put in an asset tracker, it was this size and it was these frequencies. And then the cloud has calculated, okay, for this, it recommends me to put the antenna here in the corner and with this much clearance area. This is the components that we are recommended to use. It's the trio for those frequencies. Here's the matching network that will enable it to operate at these frequencies. And then here I get both the S11 and the antenna efficiency. So with the antenna efficiency here, I'm actually already now able to compare and calculate whether how my ability to certify, whether I'll be able to meet certification requirements without having done any hardware work. So this really enables us to do an early feasibility of our IoT device development. So let me jump back to the presentation here. So with that, we want to invite you all to go and try this tool. It's for free. So you go on ignion.io/Nordic, you fill in the form, you only need to put in the communication standards you want to operate at and the frequencies and your PCB size and your contact info. And then within 24 hours, the cloud will have sent you a report with all the details that I just showed. And you can do this with any upcoming project you have, or also with an existing project just to get to know the tool. And from the submissions in this week, we'll draw a winner of a Nordic Thingy 91 and an hour consultancy with one of Ignion's antenna experts to get you a head start with your next project. So with that, we want to get started talking about the design journey for when you're developing your next and integrating your next antenna solution in your product. So for that, we have just 2 polls to get us started. So Peter, I don't know if you can pull the poll up for people. We are asking in the first one, what is the most challenging part of antenna integration for cellular IoT? So we're curious whether it's difficult for you to choose the right antenna component, whether you think it's harder to integrate it and tune it right, or if it's harder to do the planning of the amount of resources needed for the antenna part of your development project. So if you can please click what you think is the most challenging now. And then we'll move on to the next one. Just one other poll. And that is, what is the size of your IoT device? And here we want to ask you, what is the longest PCB dimension on your device? Is it more than 10 centimeters? Is it 5 to 10 centimeters? Or is it less than 5 centimeters? And this has a huge impact on the performance of the antenna, which is why it's important. So if you can please select what is the size of your device. And then Peter, I don't know if we can pull up the results. Okay, so Jaume, most people think it's challenging to integrate and tune the antenna. So I think that's something you can definitely elaborate a little bit more on. And for the other poll? Let's see the results. Most people are developing a product that is between 5 to 10 centimeters in the longest dimension, which is very in line with what we see. So that is great. Jaume, you will also explain what that means for the design. So with that, I will give the microphone to my colleague Jaume.
Thank you, Johan. Well, the results of the poll are very illustrative. I couldn't agree more. So precisely, we are going to answer those questions, because the design of the integration of antennas in devices has been hard part, but you will see that with the design journey proposed by Ignion, this is going to be predictable, this is going to be fast, and this is going to be very easy for designers in the cellular and GPS space. So let me introduce our virtual antenna design journey that will allow you to significantly simplify and speed up the design cycle by converting the device design and antenna integration in a more predictable and reliable journey. Everything starts, as we saw, with the Antenna Intelligence Cloud. It's a software-driven feasibility analysis service, very fast, in less than 24 hours, and some even in minutes, depending on the frequency bands of operation. No expensive prototypes are needed anymore. Each time you need to assess the performance. And it can be predicted from the very beginning as to allowing you to take go or no-go decision in the early stage of the design cycle. Therefore, allowing you to increase performance, shorten design cycles, reduce time to market and cost, eliminate design risk, and accelerate your innovation. The journey starts with this Antenna Intelligence Cloud request. It's very easy to use. If the results provided in the report, those in terms of efficiency, the total efficiency, are aligned with your expectation and goals, you can move to the design stage, which is to generate the design files, the Gerber files of your PCB, and check that all the design recommendations provided in the Antenna Intelligence Cloud report are followed in your Gerber file. You can follow executing a more accurate advanced simulation through any of the electromagnetic and microwave software that are available in the market, such as CST, Microwave Studio, HFSS, FECO, Opteni, Cadence. We always advise doing that just to be sure that the performance is not affected by the integration of other components, the battery, the casings, and to allow you to tune it in case of needed. And tuning is quite easy because, as you saw, the virtual antenna, it comprises the virtual antenna product, a matching network, and the ground plane. So the flexibility of the matching network allows us to tune to the frequency bands of operation without touching anything of the antenna part. So if the performance is meeting your expectations, you can validate the Gerber files, being sure, for instance, that the new components, the battery or the casings, are not affecting any relevant parameters from the antenna perspective. For instance, the batteries are not in the clearance area. And if everything is correct, you can build your prototype and tune it if needed. And finally, before moving to a certification stage, we always advise executing a pre-certification test to be sure that the total rated power and the total isotropic sensitivity, TRP and TIS, are going to pass the certification target established by your network operator. So next slide, please, Johan. Okay, so let me follow our proposed design journey through this example. Let's imagine we want to design a tracker device with a PCB dimension of 100 millimeter length by 50 millimeter width for covering narrowband IoT LTM frequency bands, 700 megas up to 960 mega in a low frequency region, and from 1.71 giga up to 2.2 giga in a second and high frequency region. The first step we propose is to assess the feasibility of the solution in the fastest and easiest possible way, which is the request of our antenna intelligence cloud by simply filling the basic information we have seen before and a complete report, including the proposed antenna chip, the design recommendations to integrate it inside your PCB, the proposed matching network topology, the bill of materials, and as well as a rough estimation in terms of S11 and efficiency is given in that report. In this way, you can assess from the very beginning of the project if the performance of the solution is aligned with your expectations, or in contrast, you need to apply some modifications to achieve them. For example, the variation of some relevant parameter from the antenna perspective, such as the PCB size. You will see now that changing the PCB size has the degree of freedom of improving or changing the efficiency of your device. So we are going to see later how the PCB size plays a significant role in the antenna performance. And you could test it through the Antenna Intelligence Cloud service. You can know now which will be the appropriate PCB size to fulfill your expectations. And everything without requiring expensive and time-consuming prototypes, just in less than 1 day, even minutes. You have this feasibility analysis and take your go or no-go decision. So next, please, Johan. So in here we have analyzed several PCB sizes from a large, medium, short, extra short, and extra short with a round shape. And as you can see in the graph, how this impacts the total efficiency of the device. The trend is quite clear that the shorter the PCB length, the less the efficiency you can get. And especially this is more critical in the low frequency bands of operation, around 600, 700, you can see that how the efficiency drops. And this data is very interesting because you can decide which PCB size you should have. For instance, if you want to have more than 10% efficiency in the low bands of 698, you know that we should use large or medium or short, but we can know with extra short. And this is very convenient because you can decide that at the very beginning of the project, minimizing any risk and reducing the design cost. Okay, next, please. Now, let's translate this efficiency in terms of TRP, which is more related to a certification process. And we're going to use this basic equation. The TRP, the total radiated power, I mean the power that is radiated by the device into space, is equal to this very simple formula. It's the output power of your transceiver in dBm plus the total efficiency in dBs. And how we can use the total efficiency in the last graph related to certification. So let me elaborate that. Let's imagine that we want to certify in America with AT&T, for example, and we know that for small devices, less than 109 millimeter, the TRP, the minimum TRP to certify, it's 10 dBm. So this means that for the large and medium PCB board, we can have much more TRP. So we have enough margin to certify. And even with the short PCB, we have 15 dBm, 5 dB above the target. But with the extra short PCB and the extra short with a circular shape, we are very close to the target. And this means that we should increase the PCB size to be in a safe position that we are going to fulfill the certification. Now, if
let me just add that we calculated these based on the NRF 9160 output power. So that one is outputting 23 dBms, right? And then it's combined with the antenna efficiencies that Jaume he showed just for.
Yeah, thank you, Johan. And now let's move to another example. For instance, in the EMEA region, and imagine that we are going to certify with Vodafone. Here, there are some kind of other rules. If the PCB is more than 50 millimeter, the TRP should be above 12 dBm. In this case, no matter if the PCB is large, medium size, or extra short, we are quite in a safe position to fulfill the certification. we have more data that we are going to illustrate where you can find this data for other frequency bands. And finally, for the Asian, for the China region, since there is no certification, this is not as critical, but always total efficiency plays a very important role in coverage and battery life. So always we need to ensure a minimum efficiency to guarantee the battery life and coverage. So next, please. Not only the ground plane provides a degree of freedom to increase the total efficiency, but in some circumstances, especially for small ground planes, and when I say small, we have the reference of 50 millimeter length. In those cases, a passive matching network, which comprises lamp components such as inductors and capacitors, cannot meet all the frequency bands. You can tune in some frequency bands, but since the platform is small, there are some physical limitations for an antenna technology. So you can focus on some bands. For instance, in the gray color, you can see that we can have 14% efficiency in the lowest frequencies of 698. But for instance, it's very poor match at 880, 960. And as a result, the efficiency is 0.5%. So what we can do in this scenario? Well, one thing will be to increase the PCB size, but imagine that we are very constrained by marketing size that we shouldn't increase the PCB size. Then another option, another degree of freedom that we have at Ignion is to use a tunable solution. The tunable solution means that instead of using only capacitors and inductor, we can use a switching mechanism just to tune only at the frequency band we are going to operate. And in this case, I have here, this is a real example, engaged with a Nordic transceiver, and the PCB is 50 by 50, one of the Trio MX10 virtual antenna, and it has a Corvo switch that is monitored by the Nordic RF9160 just to set a particular state of this switch to match at the frequency band we want to operate. So if we go back again to the result, you can see now that with this strategy, which is very compact, it's only one switch. At the bill of material, it's 5 or 6 lamp components in addition. Now the results are in the green lines, and the efficiency is much above. For instance, if you go to 880, 960, with the passive was only 0.5, now we have 20%. It's more than 40 times more efficiency. So you can see that you have these two options, or increase the ground plane if you can, and if not, use this tunable solution to match only at the frequency bands you want to operate. And this is something easy, is because it can be engaged, and all the protocols are standard and with the Nordic RF9160. So next, please. Now in the Gerber files, some basic tips just you should have in mind, especially when reviewing these Gerber files before going to the production of the PCB. You should take care that the position of the antenna chip component is the same as the antenna intelligence cloud is providing you, that the path layout is fixed, that the matching network is close to the transceiver, less than 5 millimeter will work to minimize losses, that the matching the transmission line from the matching network to the transceiver is 50 ohm, and especially the ground plane. The ground plane should be a continuous ground plane. At least you have 1 or 2 ground plane layers. So those ground plane layers should be a continuous conductive part. And also, we should avoid any traces, any component in the clearance area. And let me illustrate an example in the next slide. The Gerber files was fine, but at the end, big batteries were put on the PCB and covering most of the clearance area and surrounding the virtual antenna product. This is a no-go option because, well, at the end, we need some space to radiate. So this is always convenient, avoiding any component, electronics or metallic components in the clearance area at the top, bottom, even in the intermediate layers of the PCB. Next, please. So if you follow all the Antenna Intelligence Cloud recommendation in terms of antenna position, clearance area, the matching components, once you build your prototype and you test it in terms of S11 and in terms of total efficiency, you will realize that you don't need any human fine-tune of the matching network. Everything will be very similar to the simulation. And just let me show this example. In here we have on the top right the trio chip antenna component, which works for cellular IoT in the green line on the plot on the left. And you can see that the green line in dashed line and in continuous line, which is the simulation, and the measure lines are in a very, very good agreement. And also for the red one is for GPS at 1.57, belongs to the tiny component that you can see on the PCB. It's on the left. This is the duo antenna booster that, besides being very small, it does not require clearance area beyond the antenna footprint. Okay, next slide, please. It's not only important the frequency bands of operation, but also the use cases. Some devices may be on a pallet for tracking, even in a wall, on a human or an animal body, on a container. So all this environment is going to impact the performance on your device. So in here, what we have is we took a particular PCB size of 100 millimeter by 50 millimeter, and we just did the analysis on how the efficiency changes when the device is touching a material, 5 millimeter, 10, 15, 20, and you can see the results in this data. As a nutshell, for wood, it's quite transparent, so you can have your device very close to a wood pallet that the impact is going to be very minimal. For concrete, it's quite transparent in the low frequency bands of 800, 900, and also some absorption, minor absorption is observed around the frequency bands of 1.7 up to 2.2 giga. You can see from free space with the concrete, you see a reduction of efficiency of about 1 dB. However, the most critical environments, as you may know, it's a human or animal body, and even a metal body. Once you have your device close to those devices, there is on one hand there is absorption, so losses, and the other hand it's the tuning. The tuning is something that we can solve by changing the matching network. We can readjust the matching network, but absorption is something that it exists per se. And in here, for instance, for the human animal body, the absorption may be even 4 dB, 5 dB. And the basic rule is, well, it's quite obvious. As long as you can space the device, more space from the human body, the better. Sometimes it's not possible, but this is the basic tip. For the metal case, not only spacing from the metal body, imagine a container is an option. More than 2 centimeters will be recommended, but also if you have the freedom to move the device and put the device close to a corner, this will reduce or minimize the absorption due to the metal casing. But again, the human animal body and metal are very particular, and we should consider to tune the matching network in case on the device, if the device is in these scenarios. So next, please. So now to summarize this journey that is going to simplify the integration, to simplify and make it the life very, very easy for designers. From the very stage, which is the feasibility using the Antenna Intelligence Cloud, you have here our link, and we invite just to use it from today. It's free of charge, very easy to fill the form, and you will get the results. You will see how fast, and you can play with it. Imagine if you have in mind a design, you can start with a size, and then you can see by changing the PCB size how the PCB size impacts the total efficiency. So you will be familiar without being an antenna expert, because this is not needed anymore with virtual antenna. We are here to make the process very fast and very easy to use. For the simulation case, step 3, for those of you having the CST Microwave Studio, we have all our virtual antenna products available in our webpage in this link, so you can download our virtual antenna and grid models, and they are ready to use with your 3D and with your 3D model, and you can start your simulation and with any kind of our virtual antenna products. And for the rest, for steps 4 and 5 and 6, we have this information you can find in this link page. And always this is at the end, it's something that this allows you to be quite independent, but obviously Ignion and Nordic, we are always here for you to help in case you need always some assistance in any of these stages. So next, please. So all this journey, all this easy and fast journey is summarized in this very nice document that we have prepared for you, the design guide for cellular antenna integration. As we saw, this is one of the most difficult problems to integrate the antenna. So I think this document is going to solve most of your questions, or I would say the whole questions. If not, please contact us. And you can download from today, and you will see how easy it is now to embed your antenna using Ignion's technology, Nordic technology for your next cellular IoT project. So with that, we hope that this has been useful, practical, and from all the colleagues from Nordic team and Ignion team, we are thrilled to be here with sharing this information with you guys. And thank you very much.
Thank you, Jaume. I just want to connect a couple of other comments on this design guide. All the data and the slides that Jaume has shown now, all the data and more is in this design guide. From all the measurements we've done, we've produced the different board sizes, and we have done the measurements in the lab with the materials, with the different sizes. So this comes from a lot of work in making it easier for you to just go in and read and see how the antenna performance is affected in all these different scenarios. So please use this as your guide to your next feasibility study of your next IoT project. With that, I will stop sharing my screen and we will move into Q&A, I believe.
Yes, that's correct. There's been many good questions during this webinar, so thank you for all the questions. If you suddenly come up with a question now, just put it in the question box in the webinar platform, and we'll try to answer it as we go on. Any questions to Ignion will be answered by them, or any questions towards Nordic will be answered by me. So let's just start with the first question here. Chip antennas have existed for decades. What's so special about Ignion's virtual antenna chips?
Johan, you want me to handle or you want to answer?
I can answer that one. So the traditional chip antennas, they are resonant, so they can operate within their specific range of frequency that they are designed for. The virtual antenna technology is non-resonant, meaning you can tune it to any frequency, and that means that it has large flexibility. And also when it comes to detuning throughout the project, you can get it back because you can easily tune it with the matching network. So that the flexibility is the key difference. It makes it a lot easier to build a high efficiency device than it does with sort of traditional chip antennas.
Nice. Another question here. What is the radiation pattern of the virtual antenna solutions?
I think I can handle that. The radiation patterns are quite omnidirectional, quite isotropic. It's like an sphere, which is convenient for this kind of application where you don't know where the hub is and where you don't know where the incoming signal. So at the end, it's very, very quite omnidirectional patterns.
Good. Another question here. I think this was shown during the webinar, but can I use the virtual antenna for other wireless technologies than cellular and GNSS?
Yes, you can use it for any wireless technology. Actually, all the way down from in the 400 megahertz region up to 10 gigahertz. Any wireless technology that operates within that span, you can use the virtual antenna technology.
Nice. Here's another question. What can we do for circular PCBs?
So the Antenna Intelligence Cloud will simulate your square PCB. However, our team can easily also simulate it for you in a circular shape. So what I will recommend you to do is just fill in an Intelligence Cloud report with the diameter of your device, and then once the cloud has sort of given you a first result, which is actually often close to what the circular will be, you can follow up with the Ignion team to do a circular simulation as well. And I just want to highlight that we have a very interesting roadmap of our cloud solution with more and more features being added in the future. So also related to this theme, please keep an eye out for future announcements from our side.
Nice. There's another question. How can I simulate the multiple antennas on the PCB using the Antenna Intelligence Cloud?
You can just select add communication standard. You can select multiple. So for example, here and when we're talking about the thingy, for example, where you do cellular and GNSS. So you select the cellular part, you select the GNSS part. You could even also add a Bluetooth part if you wanted that. And then you will receive a report with the 3 antennas. It will today, the cloud is automatically calculating your request on 1 antenna. If you select multiple, it will go to our engineering team. So there will be a person that will provide you this report. But again, be on the lookout for new features being added.
Perfect. So there's another question here. So the cloud simulation is great, but what if I need to place the antenna in another place than what's suggested?
And again, the cloud will recommend you on a bare PCB level the placement. And often you need to move things around, right? And it's we can do further simulations for you where it's placed in another place, or as Jaume mentioned, when you do your 3D simulations using the Ignion libraries, you can do it yourself in the CSTs and the microwave tools. You can do these simulations yourself also. So you can do it yourself, or we can help you. So both is possible.
Good. Another question here. Are the simulation models also available for ANSYS HFSS?
They are not yet, but it's planned to have also in HFSS very soon. Yeah.
With regards to the cloud solution, is it supporting also application material for wood, human body, and metal shown there?
No, it is the free space performance of your device. But you can use the results in the design guide to see how typically the effect is from these different materials, and then translate them into your own feasibility study. And obviously, here at Ignion, we are ready to help you do those assessments and do those measurements if needed in our labs.
Good. Do Ignion simulate the impact of temperature to antenna, including a couple of passive components for the matching network?
So far, this is done by the quality insurance process, and we have all this process following the temperature range that goes down. Everything it's operating down from -50 up to 128, I guess. So this is the range that everything it's working with our technology.
Good. So there's a question here. If I were to begin with level 1 of the antenna design learning, can anyone or can you suggest what wireless technology I should start with?
I would suggest to start with a Bluetooth device. 2.4, very simple. You use the Antenna Intelligence Cloud. You can build your prototype. You can actually tune it yourself. You can measure it on your VNA in your lab to see that it is tuned to the right frequency, and you will actually be able to play with the matching network yourself in the lab. And then from there, you can move on to the cellular IoT, where you need to cover multiple bands and multiple technologies. That is obviously more complicated, where you can also use these tools. But to just get started and get familiar, a little Bluetooth device would be recommendable.
Nice. Here's a question. Can we simulate your antenna in commercial software? How can we get the antenna model?
Yeah, I can take that. Right now, we have all virtual antenna products model available in our web page. You can download in the link that you saw in the presentation for the CST Microwave Studio. So you can, if you have CST, you can do your import our virtual antenna product, design your matching network, put your PCB, your plastic covers. So at the end, you are able to simulate the S11, the efficiency, the radiation patterns, everything. So right now with CST Microwave Studio, all virtual antenna products available in our web page.
Awesome. What kind of polarization is your antenna using?
Yeah, I can take that. Usually it's linear polarized, especially in the low frequency bands. As you move to other frequency bands, may change a little bit, but mainly it's linear polarized.
Great. Another question here. Can you use the GNSS and cellular with the same antenna?
Yes, we have our Trio MX10 antenna component, which by the way it's the one that you can see here on this tiny component here. It's only 30 millimeter by 3 millimeter by 1 millimeter, and it's prepared not only to be multiband, I mean cellular IoT 800, 900, and 2 giga, plus in addition with another port, you can operate at a GPS frequency. So the answer is yes, this is dual radio chip antenna component.
Can also mention that this is the antenna which is used on the Thingy 91. So we can
That's correct. Yeah, that's correct.
Both there. If you want to evaluate. Are Ignion antennas balanced or unbalanced? I mean, how perform the full board under hand effect conditions?
Yeah, it's unbalanced. I mean, one part will be the chip antenna component, and the other part is the ground plane. So at the end, the ground plane is the main component for the radiation, and this is convenient because the transceiver, most of them are unbalanced, especially for instance the one we are working with Nordic, the NRF 9160 for cellular IoT and GPS. Both output are unbalanced, 50 on typically 50 on unbalanced ports. So mainly unbalanced.
Good. I have always been designing antennas on a 3D electromagnetic CAD software. Can I still do that with virtual antenna products?
Yeah, but now all this intelligence, it's not on the antenna part, because the antenna, it's done, it's off-the-shelf component. So you can use the component and you can move that intelligence into the matching network. The matching network provides you the flexibility to go from single band, even broadband, and multi-band in a very fast and easy way, because this design of matching network, everything can be done by software without any human intervention. So it changed the traditional way of designing devices, embedding antennas. It's not designing the antenna, it's designing the matching network, which is faster and easier.
Nice. What determines the size of the clearance area? In example, how do you estimate it without the online tool?
This is something that our experience put in this cloud will optimize not only the best chip component, the position of the antenna chip component on the PCB, but also will optimize the clearance area to balance with the best bandwidth and efficiency. So this is based on experience, and everything on the cloud will give you the best recommended result.
Great. I think we just take a couple of more questions here. There's a lot of questions, so we cannot answer all of them right now, but I will just pick the ones that I think should be answered now. Global supply chain is still very fluid. How do Ignion mitigate this?
So we are in a lucky position because the virtual antenna technology, the components, are based on FR4 material, which is not impacted by the supply constraints that we see in the world of SoCs and ICs and so forth. So we are able to still continue having very low lead times. We're talking few weeks. So we are luckily not impacted. However, obviously we live in a world of devices needing other components as well. So we do see it, but for our parts, you need not worry.
Nice. The antennas can be used for any frequency, but what bandwidth can they handle?
I think I can handle.
Yep.
At the end, bandwidth mainly depends not on the antenna part, mainly depends on the ground plane part. For instance, just to give some number, but I think this is something that you can experience with the Antenna Intelligence Cloud. We can handle as many bands as in narrowband IoT, for instance, covering from 698 up to 960, plus 1.71 giga up to 2.69 giga. So this is a huge bandwidth in the low frequency region and a huge bandwidth in the high frequency region. Obviously, by changing the ground plane, this is going to be impacted. So we invite you just to have this sense, this flavor by using the cloud.
Great. I think this one also goes for you, Jaume. Previously, you had 2 RF switches for a design using Thingy91. Now you have 1 RF switch. Is the performance the same with the 1 RF switch?
Very, yeah. It's better. It's better in several terms. It's better because we are reducing the insertion loss of the switches. So then we have more efficiency into the device, more battery life, more range. But not only that, also the bill of materials has been reduced, and also the bill of materials also for the matching network. It's much more compact, so easy to use, and much simpler. So this is like a step beyond. Always technology is evolving, and at Ignion we are always playing at the edge of the technology, and this is as a result of this collaboration, just to push on always helping the market with new technology. So this is a new advanced solution that is ready to be used.
Nice. And I think you can handle this last question of this webinar. Your antennas seem to require a lot of PCB real estate to be efficient, which is not feasible over 50% of the time from your pole. Are you working on finding solutions to do not require as much clearance ground plane?
Yes, that's in fact, we have many application nodes where we have very small clearance area, and for instance, especially for cellular IoT, because we are concerned that many people want to integrate other components. So the answer is yes, and we invite to visit our web page, where you will find application nodes of very reduced clearance area. This is for cellular IoT. And also another example, for instance, for GPS or for Bluetooth, we have also a solution that the clearance area is very small. It's only 7 by 3 millimeter, which is the DUMX10. The clearance area is as small as the chip footprint.
Great stuff. I think we should end it there with the questions. I would just say thank you very much for Jaume and Johan for this great webinar, and everyone for tuning in. The recording and the slides will be available after the webinar on our webinars.nordicsemi.com. And if you have any questions towards Nordic, come to us on DevZone or Ignion through their technical support channels. Any last words, guys?
I just want to thank you all for joining, and looking forward to see all the antenna intelligence cloud report coming in, and we will draw a winner the next coming days of our little prize.
Yeah, from my side, thank you all the attendants for being here today. Hopefully this is useful for designing new IoT devices. Thank you, everyone.
Thank you, guys.
Thank you.